Welcome back, students. So in this video we will discuss the factors that depends upon the resistance of a conductor. So you know what is resistance of the conductor? It is a property of the conductor by virtue of which it opposes the flow of electrons or electric current through it. That is known as the resistance of the conductor. It is represented by capital letter R. So now we will discuss what are the factors that depends upon the resistance of a conductor. Okay. So the factors that depends upon the resistance of a conductors are length, area of cross section, temperature and nature of the material. An activity is there in page number 206 to determine on which factors or on what factors does the resistance of a conductor depends. Okay. So, in that activity, a dry cell, an ammeter, a key and nichrome wire of resistance L, nichrome wire of same thickness but twice the length, nichrome wire of length L but double the thickness, and a copper wire of same length and same area of cross section that of the first nichrome wire. So, 4 wires are there and we will connect it in that circuit and we will check what are the factors that depends upon the resistance of a conductor. So, from that activity we compare the ammeter reading in case 1, case 2, case 3 and case 4. From that activity we get an idea that as the length of the nichrome wire increases, the current becomes 1/2. As the length increases, the current decreases. Okay. So, the resistance of a conductor is directly proportional to its length. From Ohm's law, current flowing through a conductor is inversely proportional to the resistance. Current flowing through a conductor is inversely proportional to the resistance. That is, if current through the wire increases, that means the resistance of the conductor is decreased. Okay. So, the resistance of a conductor is directly proportional to the length of the conductor. Then, when the thickness of this nichrome wire is increased, the current is also doubled or the current is increased. So, we conclude that the resistance of the conductor depends upon the area of cross section. That is, the resistance of the conductor is inversely proportional to the area. Means as area increases, the resistance will decrease. So, the factors that depends upon the resistors are, first one, length. As length increases, the resistance also increases. So, it is directly proportional. R is proportional to the length. As L increases, resistance also increases. So, here you can see this wire, the first one is a shorter wire and the second wire is a longer wire. So, as the length increases, it is having more resistance. So, the second wire will have more resistance because it is having, it's lengthy. Now, second factor, that is the area of cross section. That is the area of cross section. So, R is inversely proportional to 1/A. Means, when area increases, the resistance will decrease. Okay. Means, as the thickness increases, then the resistance decreases. Okay. So, here you can see the first wire is a thin wire and the second one is a thick wire. So, area of cross section, thickness. So, as the thickness increases, the resistance of the wire will decrease. So, the second wire will have lower resistance. Okay, it is having low resistance because it is a thick wire. Now, third point, that is the temperature. Here you can see means this is a length. The length of the conductor is this much. This is the length of the conductor. It's a length of the conductor, and this portion, that is the area. Okay. Suppose if you consider this one is the length of the conductor, and this portion, that is the area of cross section. Okay. Area of cross section. So, if I am considering these two, one having an area of cross section this much, and the other one is having an area of cross section this much. So, for this conductor, if you consider this one as a conductor, for this conductor the area of cross section is less. Area of cross section is less, so the resistance will be more. The resistance will be more. For this one, when we compare these two, this one is having more area of cross section. More area of cross section, then the resistance of this conductor will be low. Then next point is temperature and nature of the material. Okay, temperature means the resistance, for all pure metals, the resistance increases as the temperature increases. Okay, for pure metals, the resistance will increase as the temperature increases, and the resistance will decrease as the temperature is decreasing. The resistance of alloy changes slightly with rise in temperature. The resistance of alloy nichrome changes slightly with rise in temperature. The resistance of alloys like nichrome, magnesium, all changes slightly with rise in temperature. The resistance of carbon filament bulb falls with rise in temperature. Resistance of vulcanized rubber decreases by 25% when heated from 0 degree Celsius to 24 degree Celsius. Okay. So, that is about the temperature. Next point is nature of the material. Okay. Some materials have low resistance, whereas some others have high resistance. Example, copper, metal like copper, silver, aluminium, all those are low resistance. Okay. It's having very low resistance. On the other hand, nichrome, iron, all those have high resistance. Okay. So, these are the factors that depends upon the resistance of a conductor. Length, area of cross section, temperature, nature. As length increases, resistance of the conductor also increases. As length decreases, resistance of the conductor also decreases. They are directly proportional, are proportional to L. The second point is area of cross section. As the area of cross section increases, means thickness increases, then resistance of the conductor decreases. Okay. That is inversely proportional. Now, we will combine these two equations, that is R proportional to L and R proportional to 1 by A. Okay, just name it as equation 1, name it as equation 2, we will combine together. So, we will got an equation like this, R proportional to L by A, R proportional to L by A, that is R is equal to rho L by A, where rho is the proportionality constant and it is known as the resistivity, where rho is a proportionality constant, and that is known as the resistivity of the material. Resistivity means the ability of the conductor or substance to resist electric current flow. Resistance or resistivity is the ability of the substance or the conductor to resist the flow of electric current through it. So, R is equal to rho L by A, where rho is known as the resistivity of the conductor. Now, just cross multiply this one here. Just cross multiply this R to here. That is R A equal to rho L. R A equal to rho L. Now, from here we will find rho equal to R A by L. Rho equal to R A by L. So, if you consider L equal to 1 meter and A equal to 1 meter square. L equal to 1 meter and A equal to 1 meter square, then we will substitute here. So, this one will become 1, A equal to 1 and L equal to 1. So, rho equal to R. That means the resistivity of a conductor is the resistance offered by 1 meter length of the wire of the material having an area of cross section of 1 meter square. That is a resistance. Resistivity means the resistance offered by the material whose length is 1 meter and area of cross section is 1 meter square. So, if a conductor is having a length, L is equal to 1 meter and this area of cross section is 1 meter square, then that resistance is known as resistivity. The resistance offered by the conductor when its area is 1 meter square and the length is 1 meter. That is known as the resistivity. Okay. Resistivity of the material is the resistance offered by 1 meter length of a wire of the material having an area of cross section 1 meter square. Okay. Now, what is the unit of this resistivity? What is the unit of this resistivity? We will write the equation once again. Rho equal to RA by L. RA by L. Now, what is the SI unit of R? That is ohm. It is represented by a Greek letter ohm, like this. Then, area. SI unit is meter square. Now, divided by length. SI unit is meter. So, meter and meter square. 1 meter will get cancelled. So, the SI unit of resistivity is ohm meter. The SI unit of resistivity is ohm meter. Now, what are the factors that depends upon the resistivity of a conductor? Only 2 factors are there. One is temperature and second one nature of the material. Only 2 factors are there for the resistivity. Okay. One is the temperature and the other one is the nature of the material. Okay. Resistivity of silver is 1.6 into 10 raised to minus 8 ohm meter. That is the resistivity of silver. Means, if you take a silver wire of length 1 meter having an area of cross section 1 meter square, then the resistance of that silver is 1.6 into 10 raised to minus 8 ohm. Okay, that is the meaning. Okay, silver wire, the resistivity of silver is 1.6 into 10 raised to minus 8 ohm meter. The meaning is that If you take the silver wire of length 1 meter and area of cross section 1 meter square, then the resistance of that silver wire is 1.6 into 10 raised to minus 8 ohm. Okay. Now, conductors, you know conductors, resistors and insulators. Conductors means the substance which allow electric current to pass through it. That means it is having low resistance. Okay. On the basis of electrical resistivity, we can divide the materials into conductors, resistors and insulators. Conductors means, we know the definition, conductors which will allow electric current to pass through it easily, means it is having low resistance. Okay. So, conductors are substances which have low electrical resistance. A conductor allow electric current to pass through it easily. Most metals are good conductors of electricity. Example, copper and aluminium, because they are usually employed in electrical transmission lines. Okay. Because the first reason is that they are good conductors of electricity, means it is having low resistance. Okay. It is having low resistance or low resistivity. Okay. Non-metals like graphite are also good conductors. Substances which have very low resistivity in the range of 10 raised to minus 8 ohm meter to 10 raised to minus 6 ohm meter are good conductors of electricity. Silver is the best conductor among the metals because of its very low resistivity, 1.6 into 10 raised to minus 8 ohm meter. Now, resistors, whose substances which have comparatively high electrical resistivity are called resistors. Substances like tungsten, nichrome, etc. have high electrical resistivity. So, they are used to make those electrical devices where high resistance is required. High resistance is required. Here, normally the coils of electric heater, electric toasters are made up of an alloy rather than pure metal. Okay, rather than pure metal. The reason is the resistivity of alloy is higher than its component metals. The resistivity of alloy is higher than its component metals. And second point, alloys do not oxidize at higher temperature. Alloys do not oxidize at higher temperature. Okay. Tungsten is used as a filament in electric bulbs, whereas copper and aluminium are generally used for electrical transmission lines. Okay. Tungsten, the resistivity is about 5.2 into 10 raised to minus 8 ohm meter. It is having a higher resistivity. So, it is used in electric bulb. Copper and aluminium is used in electrical transmission lines because the resistivity of these metals are very low. Then insulators. The substance which have very high electrical resistance or very high electrical resistivity are called insulators. An insulator does not allow electric current to pass through it. Most non-metals and materials like glass, plastic, wood, rubber are non-conductors or insulators. Electricians wear rubber gloves while working with electrical device because rubber is an insulator and protect them from electric shock. Substances having electric resistivity in the range of 10 raised to 12 ohm meter to 10 raised to 17 ohm meter are insulators. Now, we will do two questions, that is example 12.6. Example 12.6. A given wire of material having length area and area of cross section length L and area of cross section A having a resistance of 4 ohm. What could be the resistance of another wire of the same material having length L by 2 and area of cross section 2A. Okay. So, for first wire, that is page number 209, example 12.6. A wire of given material having a length L and area of cross section A, it is having a resistance of 4 ohm. What will be the resistance of another wire of the same material having length L by 2 and area of cross section 2A. So, first wire R is equal to rho L by A, that is equal to 4 ohm. For second wire L equal to L by 2 and A equal to 2A. We will substitute here. Okay. So, R equal to rho L by 2 by 2A, that is equal to R equal to rho L by 2 by 2A, that is this 2 will be the denominator, that is 1 by 4 rho L by A, 1 by 4 rho L by A. Now, we know this much is equal to 4 ohm as per from our question. As per from our question, for the first wire R equal to rho L by A, that is equal to 4 ohm. So, rho L by A equal to 4 ohm. So, what will be our resistance? R is equal to 1 by 4 into 4, that is equal to 1 ohm. That is the resistance of our new wire. Okay, that is the resistance of our new wire. Then one more question is there. That is not there in your textbook. So, I will write the question. Find the length of tungsten wire of area of cross section, area of cross section 5 millimeter square to used for making a resistance of 750 ohm. 750 ohm. Rho is equal to 5.2 into 10 raised to minus 8 ohm meter. This is a question. Okay. Find the length of the tungsten wire. Fourth problem, I think. Find the length of the tungsten wire of area of cross section 5 millimeter square that is used for making a resistance of 750 ohm. Resistivity of the tungsten is 5.2 into 10 raised to minus 8 ohm meter. So, which equation we will use? We will use R equal to or rho equal to RA by L Just cross multiply it here. Rho L equal to RA or L equal to RA by rho. RA by rho. Now we will substitute here. What's the resistance? 750 ohm. 750 into area of cross section. Okay, that is 5 millimeter square. Okay, here R is given as 750 ohm. 750 ohm. A is equal to 5 millimeter square. How will you convert it into meter square? 10 raised to minus 3. Okay, 10 raised to minus 3. So 5 into 10 raised to minus 3 meter square. Okay, 5 into 10 raised to minus 3 meter square. Then you substitute here. 5 into 10 raised to minus 3 meter square divided by rho 5.2 into 10 raised to minus 8. 10 raised to minus 8 ohm meter. Okay, when you do this calculation, you will get the length of the wire. You will get the length of the wire. Okay, thank you.